there are two special kinds of right triangles. We call them special right triangles because the values for the ratios of sine, cosine, and tangent come out very nicely, at least in comparison to other values that you could get. We'll come back to the exact answer, exact values thing in just a minute. So set that aside for just a moment. We'll come back to that. So let's just solve these as we might normally do. So first of all, on the left, we have a 90-degree angle and a 60-degree angle, which just leaves 30 for the last one. So this is called a 30, 60, 90 triangle, named for its angles. Let's find, so we have the hypotenuse and this other leg. I'll call them x and y. Let's start with x. Let's start with the hypotenuse. So if we want to find that, we could do, say, the cosine of 60. That would work. A lot of different options for what you could do if you want to do it differently. Go ahead. But one way you could do it is the cosine of 60, which is equal to the adjacent side, that's 1, divided by the hypotenuse, which is x. So now we have x on the bottom of the fraction. So we're going to have to be careful about how we solve this. So first of all, we want x. We don't want 1 over x. We want x. So let's multiply both sides by x to bring that out of the denominator. So the right side cancels to 1, and we get x times the cosine of 60. But we don't want the cosine of 60 on the left side, so let's divide by the cosine of 60. And we can do that. Remember, the cosine of 60 is just a number. We can divide by it just like any other number, so that cancels out. And we get x equals 1 over the cosine of 60, which if you punch that into your calculator, you should get 2. So the hypotenuse here is 2. Now we have 2 of the 3 sides of the right triangle, so we could use sine, cosine, or tangent to find y, but let's use the Pythagorean theorem. So we can do 1 squared plus y squared is equal to 2 squared, and then solve for y. 1 squared is 1, y squared is y squared, and 2 squared is 4. Subtract 1 from both sides, and we get y squared equals 3. Take the square root, and we get y is equal to the square root of 3. And we'll just leave it with the absolute value, so we'll ignore the negative. And that's because we're talking about distances here. So you can see we get this nice ratio of 1 to 2 and 1 to square root of 3 if we're looking at from the shortest side. So that's one of the special right triangles. The other one is the 45, 45, 90 triangle. So you can find that the top angle here is 45 degrees just by looking at the fact that all 3 of them have to add up to 180. Then we have an isosceles triangle. So if these 2 angles are both 45, then that means that these 2 sides have to be the same length. That's a property of an isosceles triangle. So this is a right isosceles triangle, which means that the leg on the left is going to have to be 1 because it has to be the same as the leg on the bottom. Then using the Pythagorean theorem, say we call the hypotenuse x, we can say 1 squared plus 1 squared is equal to x squared. That's 1 plus 1, which is 2. And so we get x squared is equal to 2. To solve this equation, we need to take the square root of both sides. And we get x is equal to the square root of 2. And again, we'll just take the positive square root, just the absolute value, since it's a distance. So we get 1, 1, and square root of 2. So these are 2 special triangles. You will see these a lot in future math classes. You will get to know these very well, so I suggest you start doing that now, so you're getting familiar with it now. Let's talk about exact values now. So when we solved x squared equals 2, we took the square root, and we found that the answer was a number that you have to multiply by itself to get 2. And so we could write that, or we could try to write that as a decimal, but if we try to do that, we'll find that there's infinitely many digits. And we talked about this a bit when we were talking about infinity. If there's infinitely many digits, you can't write that in decimal notation. So it's actually impossible to write numbers like square root of 2 or square root of 3, or a lot of these things that the sine and cosine and tangent functions give you, can't be written as a decimal because they would extend for infinitely many digits. And so the only accurate way to write them is with the square root symbol. So that's what it means to give an exact value. It means not to take your calculator and plug in square root of 2 and say, well, this is equal to 1.41 something or other. So that would be a rounded off answer. But what we want is the exact answer. We want the mathematically perfect answer, and that would be the square root of 2. So let's use the special right triangles to fill in this chart. So let's look in the top left empty box. We have the sine of theta and then 30. Let's find where those meet up. They meet right here. So in that spot, let's put the sine of 30, which if we look at our right triangles, opposite over hypotenuse is going to be 1 over 2. So the sine of 30 is 1/2. If we look at the cosine of 30, that's going to be the adjacent side, which is square root of 3, divided by the hypotenuse, which is 2. And for the tangent of 30, that's going to be the opposite, which is 1, divided by the square root of 3, which is the adjacent side. Let's stay on the same triangle, so let's skip down to 60, and then we'll go back to the 45. So the sine of 60, that's going to be opposite, which is square root of 3, divided by, let's see, sine is opposite divided by hypotenuse, so that's divided by 2. Cosine of 60 is the adjacent divided by hypotenuse, so that's 1 over 2. And the tangent is opposite is square root of 3 over 1. Now let's take a moment to look at those. So first of all, you may notice that for sine and cosine, they're switched. So the sine of theta is the same thing as the cosine of theta. The sine of 30 is the same thing as the cosine of 60. The cosine of 30 is the same thing as the sine of 60, and the tangents are reciprocals of each other. And that's just because we're talking about the two acute angles in a triangle, and these, so these they by necessity have to be equal to each other. Let's look at the 45, 45, 90 triangle. So the sine of 45, well, you could look at either 45-degree angle for this, and you would find that it's 1 divided by the square root of 2. And then if you look at the cosine, it has to, again, be 1 over the square root of 2 because the legs are both 1. Then for the tangent, we have the two legs 1 over 1. And again, it doesn't matter which 45-degree angle you look at. Then we're going to look at something called rationalizing the denominator. Rationalizing the denominator means to take a square root that you have in the denominator and get rid of it. So for example, if we do the sine of 45, that's equal to 1 over the square root of 2. But if we take that and multiply top and bottom by square root of 2, then the square root disappears from the denominator. And so we've turned that number from an irrational number like the square root of 2 into a rational number like 2. And so we do this because it makes the mathematics a lot easier to work with irrational numbers only in the numerator. It just makes things a lot easier. So we're going to do that for this chart. So first of all, I've already filled in the sine of 45. Cosine of 45 is the same thing, so we can go ahead and fill that in as well, since it's also 1 over the square root of 2. And let's just complete that row then. So 1 over 1, there's no square roots there, that's just 1. Then if we look at the sine of 60, sine of 60 is also a number that has no square roots in it, so we'll just call it 1/2. Square root of 3 over 2 for the cosine of 30 already has a square root in the numerator and not the denominator, so we're good there. But the tangent of 30, that's 1 over the square root of 3. So we need to fix that. So let's multiply top and bottom by the square root of 3. And if we do that, then on the top we get square root of 3, and on the bottom we get 3. Let's go to the sine of 60. That's square root of 3 over 2. It already has this numerator, it already has the square root. And in the cosine of 60, that's just 1/2, no square roots there. And then for the tangent of theta, or the tangent of 60, that's just square root of 3.